Okay, well, welcome all of you. We are going to officially kick this off. On behalf of the Michigan Conservative Energy Forum and Groundwork Center, welcome to this BESS 101 webinar. I am Ed Rivet. I am the Executive Director of the Michigan Conservative Energy Forum. We are Lansing-based policy advocacy organization on all things energy. And we're very happy to partner with Groundwork Center, which is a Traverse City, Michigan-based organization that works certainly in the realm of clean energy, but they're very diverse in their activities, from sustainability issues of all types and even delivering food to the table. So they're a very dynamic organization. We're really proud to partner with them on this particular project. So I'm going to briefly introduce our three panelists, and then we're going to get right to their presentations. We welcome your questions in the chat. We will handle questions in that manner because I assume they will pile up as you hear things from each of the presenters, and then we will do our best to triage and pick maybe the most frequently noted questions in the chat. So that's going to be our approach to handling that. So joining us today is Emily Elspaugh from Jupiter Power. As you will learn, Jupiter Power is operating the first utility-scale battery storage project in our state. And Emily comes to us with as the Vice President of Development for Jupiter Power. So she knows the ins and outs of the whole process, as well as the technology of what we do, what we're bringing when battery storage facility comes into existence. Along with the couple degrees from the University of Oklahoma, I like to suggest that Emily, her background prior to this includes being a landman. So yes, you can be a woman landman, and I'm sure she is the much more charming, delightful, and less dramatic version of Billy Bob Thornton. And then she probably lives through that terrible, jokey analogy too often. But Emily certainly has great expertise, and we're really glad to have her with us. Madeline Kroll is with us. She is from the Graham Center at the University of Michigan. Her expertise is in land planning and land use, and really understands the interplay of really the effective and appropriate siting of all sorts of renewable energies technologies, not just battery, but also understanding kind of the intermix of that with planning concerns and what community concerns are, as well as the law itself and how they all interplay. Madeline knows local planning and siting very well. She and I have actually been in some very local meetings where they've discussed things like wind or solar or battery projects. So she is an on-the-ground expert and coming to us from the University of Michigan. We're pleased to have her. And last, we have Captain Richard Burke. He is a retired captain of the Las Vegas Fire and Rescue service for 30 years, but he has deep knowledge of renewable energy, solar, and battery himself, having lived in a home that was off-grid for 14 years. But importantly to us today, he is the founder of SAFE, which is Solar and Fire Education. So he travels the country and indeed outside the country, training fire departments, first responders on how to address fire safety challenges with regard to solar and battery in particular. So he's really a rare type of expert, and we're very grateful to have Captain Richard with us today. And I think he goes by Rich, so I'll be calling him that. So that's our expert panel, and we're pleased to have them. And at this point, I am going to turn it over to Emily, who is going to kind of give us the what of what a battery energy storage system, a BESS as we call it, is all about. So Emily, I'm going to turn it over to you.
Yep, hopefully everyone can hear me. And thank you, Ed, for that introduction. And yeah, so really appreciate the opportunity to be speaking to this group today. Like Rich said, my team oversees all development of our Michigan portfolio, and which is pretty vast. And so I'll kind of just go into that pretty quickly here. Hopefully everyone can see my screen. So just to touch high level real quick, our Michigan project team. So, of course, Jupiter Power, we are the developer and owner and operator of the battery storage facilities. We also use local Michigan-based firms like our Land Use Council, Dickinson Wright, and then, of course, our civil and environmental engineers. We take it seriously to use local firms because they know the areas so well. And so we strive ourselves to work with local firms as much as we can. And then for fire safety, which of course Rich is going to be covering later in his presentation, we work with fire safety engineers from the very beginning of our process. And so for Jupiter Power, we work with Fire Risk Alliance, and they were the firm that helped develop all of our engineering designs for fire safety for our Tibbetts project in Coldwater Township. And also worked with all of our the Coldwater first responders for training of our facility. And so now just jumping to about Jupiter Power, I'll quickly go over just some of our more specific Michigan-based pipeline. And so we have 4+ projects in development in Michigan and we were able to develop the first ever operational BESS facility within the state, which is located in Coldwater Township. And something else to just point out, there are different types of developers, but Jupiter Power, we are a developer that owns and operates our facilities long term. And so relationships with community is our top priority. And so it's a long-term asset that is going to be in these communities for 20+ years. And so we take working locally as our focus. And so we want to work with communities to build a relationship for the long term. So I'll kind of skip over this part just so we can get into the meat of what battery storage projects actually are and what they do. And so as you can see on this slide, what is battery storage? So our storage facilities are essentially large versions of a battery, as you know, like powering your cell phone and laptops, but serving at a larger scale, so the electric grid. Our projects are connected to the electric grid at a utility-owned substation and charged during times of plentiful or extra electricity supply, like overnight. Then in times of high energy demand, our battery projects discharge the previously stored energy back into the grid for use by consumers like homes, businesses, and other industries. Our facilities are essentially accessories to substations, so existing substations, and are energy agnostic. So we are charging and discharging kind of anything and everything that's on the grid currently. So kind of just running through this diagram real quick here. So, one, of course, is, the battery storage facility. So this is kind of a cartoon of what a facility looks like. And we are charging, the generation that is going on to the grid. So we are charging kind of the, coal plant, wind, solar, that is what we are charging. And then in times of energy need, we are discharging that electricity back onto the grid, like I was saying earlier, for those end users, like, businesses, industry, and of course, homes. And so something that, as Ed mentioned earlier, my background is, of course, in oil and gas, and I, switched over to battery storage. Something I wasn't even, really knowledgeable about is energy supply and demand always need to be equal. Because if they are not, that is when we're experiencing brownouts and blackouts. And so that is really what battery storage is able to do, is be able to provide that stability for when there are those mismatches in energy supply and demand. So now wanting to touch on, now we maybe better understand, what is battery storage doing? So what does it actually look like? What is it made up of? And so as you can see here, this of course is just a rendering of a typical battery energy storage system, but the components are all the same. And if it's a larger project or a smaller project, again, all the same components. So number one here is our energy storage system. And so you'll hear developers say enclosures, or even they might use the word shipping containers, but just to visualize what it is kind of a glorified shipping container. So if you're visualizing that is kind of what these enclosures are looking like. And then we have number two here, which is our power conversion systems, which is our inverters and transformers. And then we also have number 3 here, which is our step-up transformer and our project substation. So that also includes lighting, lightning protection, control enclosures, and the internal fencing. Something else that we like to talk about for battery storage is the size of our facilities. And so for the project that's in Coldwater Township, and that project is a 100 megawatt 4-hour system, it takes up roughly 7 acres. And so this allows us to have a minimal land disturbance, preserving a lot of the core values of communities in Michigan. So now that we've kind of talked about kind of the high level, what it looks like, I do want to go into what is in those enclosures, the shipping containers, as some might call them. And so kind of at the smallest level to start is the cell. So this is, around the size of a motorcycle battery. So it will likely just fit in your hand. So there are many cells that then make up and are put into these modules. And then there are many modules that then go into these racks. So kind of what you're seeing here is modules. So you can see they're stacked in these racks. And then there are several racks that then go into the actual container itself. And something that is really important and key when we're talking to communities is the testing, monitoring, and remote control is down to the module level. So as you can imagine, all of these racks have, many modules, and this is the module here. And we are able to monitor and know when there is something occurring at a facility down to that level. And so if there's a module that in a cell within that module that is, needing to be replaced, we will know instantly because we are monitoring our facilities 24/7, 365, rain, snow, anything that's going on. We know what's going on with these facilities and can respond to them within seconds. And so now just wanting to talk about why Michigan. We talked about what battery storage is, how it operates, the main components of the facility, but then why are these coming to Michigan? Which is a very important question. And so some of you might be aware of this, but Michigan is currently facing an energy capacity shortfall. So as you might be hearing, retiring power plants that will retire eventually, the physical grid constraints that limit importing energy from outside states. And then, a hot topic right now is, of course, load growth in the state. And so what is coming with load growth is, of course, economic expansion, like onshore manufacturing and other industries that are creating new jobs, but it is also driving new demand within the state. And so because there is that new demand, battery storage is a really good kind of key tool for the utility to be able to use to keep that supply and demand equal. In addition to that economic expansion, just grid reliability and infrastructure upgrades. So as a lot of people might be aware, the electric grid is a very aging infrastructure and there's a lot of resiliency needs. And so instead of massive upgrades for transmission upgrades, battery storage is actually a good tool to help eliminate a lot of those costly upgrades. And then, of course, even just electrification for that new load growth. There is a huge movement for industrial electrification and even individual home electrification. So all of that coming together is driving a huge new load base in the state of Michigan. And batteries are the best and quickest resource to help alleviate that constraint. So now I want to touch on, now that we're kind of talking about, of course, why Michigan, also, as a lot of you are aware, the new state siting legislation that took place. I'm definitely speaking on behalf of Jupiter Power with a lot of our statements on this slide, but there are many benefits for communities to keep projects under local control. And Jupiter Power believes that is the best way to move forward with projects like battery storage facilities. So working with the host community to make sure local control is possible and that each community, because each community is unique, kind of is able to prescribe certain requirements on our facility to meet the unique nature of that community. So usually when we're going into a new host community, I actually just pulled a template that we use when we're going in and talking with elected officials to begin with, to kind of show what the MPSC state siting guidelines are, and then how we can actually work with the township to put together a workable ordinance. So not a CREO, to help kind of guide the regulation of battery storage facilities. And then want to quickly just talk about, we're a good neighbor. I know, Madeline, you and I were just kind of talking about this earlier before we started the presentation. We kind of, joke in the industry, batteries are kind of boring in a sense. They are a huge key to helping grid resiliency. But as a neighbor and a host, and for a community to host a facility, we are really a good kind of, facility to be in these communities. As I mentioned earlier, we have a very small footprint. Then a few other items here that I'm going to mention quickly are, of course, our monitoring. So the site and battery energy storage systems will be remotely monitored and controlled, like I said, 24/7, 365 days a year. We do have security for our project. So the site will be surrounded by a fence and locked with access only by Jupiter personnel and first responders. And then Jupiter, we will have 1 to 2 site technicians on site dedicated to overseeing the safety of our facilities. And then lighting, of course, we work with communities on lighting, depending on kind of where these facilities are located. But for the base, the facility lighting will be dark sky compliant. Visually, the facility will be designed to enhance compatibility with local land uses, including screening. Our, as you can imagine, an enclosure and a shipping container isn't very tall, and so screening these facilities are actually quite easy. And so we can definitely incorporate a lot of screening into the design of our projects. Sound, of course, will always be in compliance with township ordinances. Traffic is minimal, so approximately 1 to 2 daily trips and light duty service vehicles. There's no odor, there is no groundwater use, there's no pollution or discharge of our facilities, and there's no dust during our operations. And this one, to just quickly just go over local community benefits. So this is actually ripped from a new one of our projects that we're just currently permitting in Saline Township, where we received our special land use permit earlier this year. And so, just to kind of quickly flash again, this is a 100 MW 4-hour system, and these are the benefits that the community will be receiving over the life of the project. And then, at this very end here, this is actually that community readiness grant from Eagle that the township was able to receive. So for a project our size, they receive, and actually this actually should be $500,000 for our project size. So they're getting quite a bit of, tax revenue injection in addition to that Eagle grant that they were able to apply for and received. And so I will stop there. Want to make sure I'm keeping time. I know we had a limit to 12 minutes. So we, of course, will, for Jupiter Power, we cover fire safety, but I know Rich is on today to cover that. But that is a huge part of our training and education of communities. And it is, our first responders are part of our projects from day one. And so we work with them, of course, when we are designing our facilities. And then once they're operational, we do annual trainings with first responders to make sure that they know our facility and are ready in the event of something happening at our site. So I'll stop there. And so appreciate everyone, listening and hopefully learning a bit about battery storage.
Thank you, Emily. And I do want to encourage folks to go ahead and put questions in the chat that come to mind as the presenters are doing their thing. So let's pivot over to Madeline. I know she's got some slides, so we're going to let her take over the screen and share this perspective on battery storage for Michigan. Take it away, Madeline.
Super. Thank you, Ed. You should see my slides right now, right?
We do. Yes, we do.
Perfect. Awesome. Hi, everyone. Thank you so much for having me here. And thank you, Ed and Emily, for this introduction. I think my next piece is lining up to this very nicely. I'm excited to just kind of like very high level battery storage 101 from my perspective. And I'm a planner by training. I joined U of M 3 years ago, where I'm this funny researcher that does a little bit of research on the impacts of large renewables on communities across the country. But more so, I really am oftentimes in townships and communities and help with the very specific planning and zoning kinds of questions when we think about siting and permitting these big projects. And so the University of Michigan, our team has a relationship with the State Energy Office within Eagle since 2019, and it evolved, and over time, we're now we're leading this Renewable Energy Academy that's really supposed to be for local government officials, so planning commissioners, township supervisors, planning staff, to find resources on all of the things renewable energy and energy storage related. And so as part of that, I frequently speak on battery storage. We are creating resources. I'm going to plug it because I'm going to plug it 5 more times. A guidebook on battery storage that is really kind of for the layperson, highlighting some of the things that Emily has actually already highlighted, and like really what is BESS all about, and what from a zoning perspective do we need to know in this kind of space. And so that's the kind of things we do. I think to understand siting and permitting these big projects, what's a key thing to start with is really acknowledging the 2023 bill package on energy that was passed by the legislature, which included a bunch of bills on energy, one of which being PA 235, which, as the first Midwestern state at all, now Michigan has an energy storage mandate that we want to go from almost 0 to 2,500 megawatts in a very short time period, which is really a big deal for Michigan. There were other standards in this, or other mandates in this, and upping our renewable energy target and those kinds of things. And one of the key issues identified to reaching those targets really was permitting. And so part of that energy package was another bill, PA 233, which Emily has already alluded to also, which really changes how local governments think about permitting these projects, because now there is an option for a developer of a project to, instead of getting local approval, be able to get a permit for a project from the Michigan Public Service Commission under certain conditions. There's lots of caveats with this. Unless a local government has a compatible ordinance, so one that's kind of in line with what is spelled out in the law. So that in the past 2 years has dramatically changed how local governments think about these things, and kind of the options that they now have. And this being an option is also really making Michigan kind of a special way of state permitting, as other states are looking towards permitting reform. So this law only applies to the really big storage projects, the ones Emily is building, with 50 megawatts of a nameplate capacity and larger. So we're not talking about like the Powerball kind of projects. This is the big stuff. In the past year now, developers had an option to take battery projects to the state, to the Michigan Public Service Commission, but they actually haven't for BESS yet. So far in the past year, we've had 3 solar applications come through the state, and there's lots of paperwork and a lot of thousands of pages of application material that MPSC is sifting through and determining these applications complete or incomplete. So that has been a fascinating process for me to observe from the sidelines. In the meantime, at the local level, we can peak towards that Renewable Energy Communities Award that Emily mentioned, which is a grant by Eagle that communities are eligible for if they have permitted a big solar, wind, or storage project. And within the past year or 2, there have been a significant amount of projects being permitted. This is a great source of information for me because like public national data sometimes is a little bit delayed on what is coming online. But the RCA map that you can access online is really a good indicator of where very recently these kinds of projects have been permitted. There's a picture of us facilitating a workshop. We've been touring the state and explaining the siting law to communities and helping them develop ordinances as they are preparing for or responding to application proposals. So projects have been permitted and there's a ton more in the pipeline. This is a screenshot showing projects that are under consideration that are in the MISO queue, which is basically a process that developers are going through. It takes multiple years to see what is the cost of connecting a project into the grid. Is there space on the grid? Which gives us an indication of where developers are looking at to develop BESS. But I also want to say not all of those are necessarily going to be built. But you see here all of these gray dots kind of all across the state of the lower half of the state. And what I find really interesting is the majority of these megawatts that are considered by developers are actually standalone BESS, which is in line with what Emily explained. It's more so a transmission grid asset rather than being necessarily paired with renewable energy. Oftentimes people think about battery storage in the same context as renewables, but they're, like Emily said, kind of energy agnostic and are happily functioning on their own, standalone, not necessarily having to be paired with a generation source. So this is just to give you kind of an idea of scale. So we have an energy storage mandate of 2,500 megawatts, and we have way more than that in the pipeline. So there's a lot of interest in developing BESS in Michigan. I'm going to keep this very, very brief because Emily had explained that already a little bit, is like the kinds of things batteries do for the grid. So like when we look at the benefit these provide to the grid, BESS play a variety of different functions to the grid, from arbitrage, which is really referring to charging electricity when prices are low and discharging it back to the grid when prices are high, kind of balancing out this energy supply and demand piece of it. They help with frequency regulation, et cetera, et cetera, et cetera. Many, many, many things. But for a local perspective, so this is the benefit at large. What is the questions I often get? But for us, what does it mean for us? And I could spend hours talking about kind of the pros and the cons, because every energy infrastructure has pros and cons, and I think acknowledging those sides helps. But I'm going to keep it brief for you because of the limited time. But the key piece, the key on like the local benefit side for local governments is really this economic development opportunity that battery storage projects bring. Because it's a small footprint. Again, my bias is kind of solar. So if we're thinking about like hundreds and thousands of acres of solar, comparing that to BESS, it's a small footprint with a significant dollar bill on it that is kind of streaming into communities. I do want to have a caveat there with the tax payment, because there's always in the past too for wind and solar kind of changes to how tax tables work. And so we are currently working on a resource for local governments that is breaking down tax implications of all three wind, solar, and storage technologies. For wind and solar, we have policy briefs and calculators where communities can punch in like their township, their school district, their megawatts of solar, and get out how much over 30 years this project's going to be generating. For BESS, we don't have that just yet, but hopefully sometime in the future. But in the meantime, we have that guidebook that we are working on endlessly and hope to publish it by the end of the year, that really dives into all of those fun things of tax revenue coming in versus a one-time payment, either in form of a community benefits agreement or the Renewables Ready Communities Award, that grant from EGLE, and how communities can be really strategic about leveraging those, and all the kinds of things that they could do with this funding coming in. Obviously, there are other local benefits to it, but I would say that this is kind of the key one. On the flip side, the key local concern, and we've already heard that too today, is really this fire safety piece and the risk of having thermal runaway. I don't know in how far Rich is going to cover that, so I think I'm just going to punt it to him. But I just want to acknowledge that yes, there is a concern with fire safety risk, and through fire code, through kind of best practices evolving very quickly in the industry and among firefighters and fire experts, this concern is addressed. And I think a key piece of that is really that now we kind of have established in the Michigan permitting process, really the collaboration between developer, fire department, and first responders and local governments, so that everyone's on the same page, everyone is receiving training, and has the resources to, in the very rare case that something happens, to respond to that. And so that's kind of a key piece to the question. From a zoning perspective, there are some other concerns, some of which can be addressed through zoning, such as like, how loud is a storage system is a question I often get. Or how do I screen shipping containers? And yes, they're maybe not as tall as a wind turbine, sure. They're easier to hide. And then I help communities kind of figure out how that can look like in a zoning ordinance to address those concerns. Coming to time, I have a ton of resources that I'm just going to highlight here on our webpage. We have all of these zoning resources or resources specific to PA 233 and all of what that means to local governments. And I also just want to shout out again, Eagles Renewable Energy Academy and all of the resources that we're together developing for communities. And with that, I'm going to hand it off back to Ed and look forward to your questions later.
Great. Thank you, Madeline. A couple of things. We are going to be making a link to the recording of this webinar available to all of you that have attended, and in fact, probably to those who haven't made it that registered. So you'll have access to it, which will give you access to the slides. So we're not going to be sending out a separate attachment of the slides, but you will be able to review them by pulling up the recording. The other thing is I've been misspeaking the whole time. We don't have chat available. We have Q&A available. And I know the rest of you who are ignoring my, my misstatement have been putting things into the Q&A. So I'm seeing that populating well. And if you do have questions, put them in the Q&A. My bad. And with that, we'll turn it over to Captain Richard to discuss safety elements.
Great. Thank you. Everybody can hear me. My voice is a little rough. I spent 8 hours yesterday teaching firefighters from New York, San Francisco, Cal Fire, some of the busiest areas who've actually dealt with the lithium-ion batteries. So a little bit about me. I'm a retired firefighter. I'm from England originally. And basically, I met an American girl 35 years ago, still married to her, and had to get a real job and became a firefighter. And basically, I'm a pioneer of solar and batteries. I was one of those people that lived off the grid before this was a thing, before it was anywhere. And basically, I've been concentrating on fire safety for 20 years. And I spent the last 10 years teaching firefighters all over the world. And there are problems with batteries. This is a new technology, whether it's solar or batteries, that's come into our world. And it poses a problem to firefighters and civilians and communities. And what I do is I teach what are the risks. You're joining this webinar because this stuff's going in your neighborhoods. Is it safe? What do you need to know? So I have an 8-hour class that I teach firefighters. We're going to do this in 12 minutes. You're going to get some homework. I'm glad it's being recorded because I'm giving you guys some homework. People in communities need to know this stuff. So we're going to concentrate on the large storage and basically what's going in your neighborhood. What's going into your neighborhood is a very, very large battery. Now you have 20 to 25 of these batteries in your homes, from a vape pen to an e-bike to a scooter to your EV to your home battery. You're surrounded by these lithium-ion batteries. It just happens to be in a large box with a lot more energy in it. And so we've got to start saying, what do you need to know about that if that is your neighbor? And we've got to start with some fundamental facts. The chemistry has changed over the years. Now, there was some bad, angry chemistry going into large storage, and it caused some major problems. And we had an incident, and I've been part of that incident down in California, Moss Landing. It was angry chemistry. It should have been decommissioned, and basically it burned up, and it caused a major problem. And there's still continuing problems with it. But you've got to know in Michigan, in your neighborhoods, what you're going to get. It's not going to be NMC chemistry, okay? We can go into the long names of it, but basically you're not going to get a chemistry that was out there that they put in large storage, and it's lithium, nickel, manganese, cobalt oxide. What you're getting in your neighborhood is called LFP, and it's lithium iron phosphate. Now, what does that mean to somebody who lives in a neighborhood saying, I've got LFP as my neighbor? What it means to a firefighter and you is it's a much better chemistry. It's a lot safer chemistry, and how they're designing it and putting it in the box so it powers your community is a lot better. So we're learning. So the battery industry started with some chemistry that was very, very volatile. And now we're getting to the point where we're using a chemistry, whereas firefighters, we look at it, we burn it, we see how it reacts, what does it off gas, and how stable is it? Is it going to go into thermal runaway? What will make it go into thermal runaway? So right now, the facts in Michigan for your neighbor, who's this big box with energy, it's going to be LFP chemistry. And that's one question you can ask any developer when you go on a tour, when you go to a city council meeting. You can talk to them and say, what kind of chemistry is it? So remember that. The second part of this is, what is the gases? If there is a problem, because how these batteries work, like Emily said, is you start with a cell, a small component, it goes to a module, and then it goes to a battery. And basically, where we look at it is, can it actually happen at the cell level where there's a disturbance in it? And can it go to a fault? Can it lead to a thermal runaway, which means it catches on fire? Yes. But the smoke coming off one of those, people always ask me around the country, fire chiefs ask me around the country, Rich, what is that smoke? Is it any different than you had a working fire from a building? And what we're finding with research is no. So with the LFP chemistry, the smoke that's coming off this building or this battery is going to be very, very similar. What's the only difference is there's a lot of hydrogen. And for you to understand, hydrogen for a firefighter does not want to collect because it's very, very explosive. But we know with these battery storage systems, and Emily showed you a picture of one, what they're doing is they're not putting it in a building anymore. So again, they're getting safer and safer. And so if there is a problem, and there may be a problem, and it does burn or there's smoke coming out of it or it's off-gassing, that hydrogen just goes up and dissipates. So the great thing is they're learning from this and they're saying, okay, we can put this in a field and we can put it in a box that basically ventilates itself. It's not in a building now with a roof that can collect the hydrogen. And what we're seeing in the fire department, this is the low-hanging fruit for risk. So my job is to teach across the scale on renewable energy. And so when I talk to firefighters, our major risk is not large storage at all, because large storage has very good chemistry. It has all the testing, NFPA. It has 9540, 9548, 855, has all this testing at the cell level, module level, and at the burn test. And so we're saying, where is the danger? Because people talk. You have a lot of misinformation about this. The most dangerous thing you have is in your house. I could point out 10 things. Everybody on this webinar, I could point out 10 things that you have in your house that the fire department of New York are screaming at the top of their lungs is, we have to understand that these lithium-ion batteries, some of it is being shipped into the country and has no rating. So here's some numbers for you. Do some homework. And your home, look at your e-bike, your scooter, your drill pack, battery pack. Look at all those. You've got to do some homework on your home batteries. If it's UL 1642, UL 2054, UL 1973, look up and see if your battery packs and your e-bikes and your scooters and your vacuum cleaner battery meets 9540, UL 9540 meets UL 9548 and NFP 855. I can tell you right now that large storage going in your neighborhood that's made of LFP, very safe chemistry, that off gases hydrogen that goes into the air, has all those standards. I'm telling you right now, there's 10 things in your home that don't have any of those standards. So we've got to, as a community, understand this through our layer of technology. This touches our home, goes all the way through. We have to be concerned about important things, but let's not just run off and point at one thing and say, well, that's large, so that's most dangerous to my community. No, it doesn't work like that. The other thing is the chemistry in some of your battery packs at home is that NMC chemistry and is that NCA chemistry. The LFP chemistry was the huge step forward for large storage. So with Emily says, they're very proactive with the fire department. The trouble with the fire departments are, especially in rural areas, I deal with from volunteers all the way through to San Francisco, New York, and all over the world. I teach firefighters, but there's hundreds, thousands of volunteer firefighters. What the important thing for you to do in your neighborhood is look at the facility, go to these meetings, Ask important questions about what chemistry is it? Is it in a building? Now you know. If they're saying, oh, we're putting in a building with a roof on, you're going, no, you're not. Look at the containers, look at the chemistry, and ask the fire department, do you have the resources? Do they have the resources they need? One of the biggest things that the volunteer fire departments need is training, but they also need personnel. The volunteers are dropping, and what's happening is we have to find technologies for the fire department to use because they just don't have the people on the books anymore that are volunteering, and it may take a while to get there. So I'm very, very involved in also giving the community, saying what's out there, what's new in the fire world that can help you protect your community from these batteries. But what we're looking at fundamentally is this layer of technology coming into our world. We have solar farms too that may be connected to the battery management systems. You're going to see that in Michigan. You're going to see solar farms everywhere. Again, what is the danger to a community? The solar farm connected to a battery management system, connected to a BESS, a battery system. All these components are basically problems for a fire department, but we have solid strategies and tactics now because the technology is getting better. The battery management systems that are used in these large storage are incredible. I lived off the grid for 14 years. I lived off with batteries with no management. It was like having a preschool with no teachers in the preschool. It was just lead acid battery. It was just a riot. You just had to keep an eye on them constantly. What you have now is school monitors. You have hall monitors. You have 3 teachers in a classroom, and they're looking at every student. And basically, a cell is a student. And so where they've gone with that, where they've gone with the chemistry, where they place these is critical, and we're all learning together. That's the most important thing I tell communities is I talk to fire chiefs where there is a problem. What was the problem with the battery management system? And we'll list it. And the good thing that Michigan is developing batteries now because they're on the tail end of it. Trust me, where I am right now in San Mateo County, 32% of the cars on the road are EVs. We're seeing some major problems with an EV too. But the point is, where we are with large storage, on our pecking order on the board yesterday from firefighters from all over this country, some of the busiest departments in the world, the pecking order of what we're concerned about and what we have to really gear up for and train for, battery management and batteries, large storage is way down on our list, way down on our list. So from just a practical point of view of teaching thousands of firefighters around the country, I'm coming into areas going, yes, we need solid strategies and tactics. Yes, you have to know what chemistry they're using. Yes, you have to know what containment they're using. Yes, you have to know, is there a water supply for the fire department? These are key questions. But outside of that, start looking in your communities about where your EV is, what kind of damage, where your repair shops are for EV batteries. What kind of batteries do you have in your home? Do you drop your drill power pack? Do you replace it? So it's kind of one of those things where take your energy and start doing research of lithium-ion batteries through your homes, through to large storage. And again, really do your homework on the stuff in your home and have those questions ready for the developer who rolls into your neighborhood and says, we want to put battery storage in.
All right.
Thanks, Ed.
Thank you, Captain. All right. There are a variety of questions in the chat, but I want to try and do this as a lightning round, as the moderator asks some questions. So I'm going to ask our panelists to answer them in the shortest answer they can, so I could get to the audience, questions. But very quickly to you, Emily, a couple of questions. How long does it typically take to build the project once you got your permits and that, when the construction team starts, say from what we call ground break until you can operationalize it? And then what is the typical size of, say, 100 megawatt facility like the one you mentioned in Coldwater, or the one you're working on in Saline or wherever it is? How many acres on average is 100 megawatts? So there's your 2 quick ones.
Yep. So to cover the second one quickly, yep. So in Coldwater Township, our 100 megawatt 4-hour system is on 7 acres. And then to cover the first question, which was the duration, once we actually have our permits, and I'll even go as far as saying we have our building permits from the county. So ready to start construction. It takes anywhere between 8 to 12 months to get a 100 megawatt 4-hour system online. And so if you kind of start scaling it a little bit more, so if you're seeing a bigger project, that'll likely add a few more months, but it's a lot about the grading, foundation work, and then, that's kind of the big piece of our construction.
Great. Captain, I'm going to pivot back to you. You were talking about how large battery storage is low on the list, and you also mentioned that it is, in a certain sense, with the new designs, that it is similar to a building fire in terms of gases or whatever the case may be. But we hear stories about how hard it is to put out, say, a Tesla vehicle on the side of the road, lots and lots of water. How hard is it comparatively to control a fire, suppress a fire with this new kind of chemistry that you're talking about?
Great question. So at this point, that's where the strategies and tactics come in. My class yesterday, no one's putting water on one of those large storage. What we do is, if you looked at the picture Emily had of boxes of batteries, if one catches on fire, the fire department does the opposite that we're taught. We don't put the wet stuff on the red stuff. We actually go, okay, that lithium in there with the electrolyte, if it's burning, it's doing its job and it's burning up. What we do is that next box to it is full of those cells. And we know the temperatures because we do the burn tests. And what we do, our job in the fire department, is to let that one burn. So we don't try and put it out because it's really, really hard. We cool down the next box to it so that doesn't go into thermal runaway. So our job is exposure protection. And so that is critical strategies and tactics. That's what we teach. So we tell communities, you're going to have one of those burn. And when I went to Australia, when they had some mega packs burning, they were like, do we put water on it? No, just let it burn. And that's when you say most of that smoke you see is hydrogen. And if it's being burned off, there's no hydrogen. And the smoke is basically, at this point, that's why you put them away from communities. You look at the smoke plume, just like you would a building, and go, does that smoke look like it's drifted to those houses? Yeah, we would do a shelter in place. So we don't put water on those.
Madeline, quickly, Emily did mention in her slide a variety of things that batteries facilities don't have or don't use. They don't use water. They don't. So on a comparative scale, when local communities are doing planning and zoning, and someone wants to come in and put in, I don't know, a tool and die shop or some other form of factory or something like it. Comparatively speaking, when you look at the elements of what a local official has to look at, I happen to chair the planning commission in my township. How complex or how much more involved or less involved might it be to address the elements of a battery storage from a zoning perspective?
That's a question I could speak hours to. But I think in a nutshell, I think at large, this is it is a little bit, it's a sophisticated technology. And so I think with that comes additional studies and documentation, or all of the certification requirements and fire code standards 855, and checking compliance, or at least to a degree understanding what is being submitted to a local government, I think goes above like your standard manufacturing facility. But that goes to say, I think also that there are mechanisms in place where local governments can get support to review applications and use extra mechanisms to get these kinds of things paid for, to properly review. I don't know that it totally gets at your question, but I think so when we compare this to solar or to wind, then obviously we have a very different footprint. And so that alone kind of upscales the kind of public notice that needs to happen, because now with a wind project, you're touching a lot more neighbors and properties that kind of need to be informed and engaged. So, and the footprint element is obviously very different from a battery storage facility.
Right. Okay, couple questions that are a little more on the technical side, and then I'm going to go to some additional questions about really folks are very interested in batteries as they're utilized or may affect the grid. But I ask a couple that are about the operations themselves. So maybe this is Emily and the captain. One is about the noise level and how it is mitigated. Obviously, it would be with the inverters and so forth, the home. What is that comparatively like in terms of, say, a noise level requirement in an ordinance, Emily, and what mechanisms are needed to kind of mitigate the sound?
Yep, no, great question. And, if you have a substation, like a utility substation in your community, that might actually be a good place to start. So it's very similar to that kind of hum that you hear from a utility substation. A lot of the noise is actually coming from our HV units on our sites to keep our facilities cool. And so to help mitigate that, just to kind of start at local ordinances. So we will always comply with local noise ordinances. And so usually depending on how large the project parcel is, for a 7-acre project, a lot of times if we have like a 20-acre site, that noise will never go past the property boundary. But just to talk to some of and developers will do noise studies and should be doing noise studies. So like Rich was saying earlier about what questions you should be asking developers, ask them about the noise study that they generated. If they haven't, they should be, to be able to show you kind of what that noise is, how it's kind of interacting and going, past, if it is going past the property boundary. But some mitigants for noise, of course, are berms. We have actually built and permitted a berm for our project in Saline Township. So berms, of course, help eliminate that and are a more natural feature instead of, a noise wall or additional fencing that might not fit the natural landscape of a community. But right, berms, noise walls, additional fencing, additional vegetation screening are all types of screening and mitigants to help with noise if that's a concern of a community.
Okay. Another technically related question, and this is probably Emily and Captain, is are there some forms of fire suppression that are built in or engineered into it? And I would ask a parallel question. Is there monitoring capacity such that you might get an indication that there is a cell failure, there's maybe some heat buildup, and so you have the capacity to even remotely shut down a particular module or unit? So both, is there fire suppression technology built in, and or is there a mechanism that you can maybe help preventatively address the threat of
Yeah.
runaway fire?
So for me, there's definitely suppression out there, and it's developing. Like I said, we're with LFP chemistry. We know when thermal runaway, when it catches on fire. We know the cell structure of it, the anode and cathode and separator. We kind of know what is causing problems, overcharging, dendrites, and so on. So we're saying, yeah, things can come up. So can we get a handle on it immediately? So yes, there is suppression, but one of the biggest things we've found is if it gets past the suppression part of it and it gets out, and suppression doesn't always do the job of suppressing it and stopping it because it's a chemical reaction and we're not dealing with our traditional tetrahedron of suppression. So the fire department work about and how they put stuff out is a chemical reaction, and you move one of those to stop the reaction. So with this chemistry, there is suppression. It does work, but you have to have the backup. You can't say that's going to work 100% of the time. Now, monitoring has what's changed the game. So monitoring of these battery management systems that monitor BESS is incredible. Where they've gone with that technology, I would say, is the linchpin to basically being safe in a community. So if you can monitor down to the module level, and sometimes they monitor to the cell level, what you're doing now is you're not going to have a module that's going to go into thermal runaway or off gas and be stressed out. It's what it would do is the system will say, okay, we're going to shut off power to that module. And so we're going to chill that area out, not stress it, and the other ones can continue operating. And I would say that's the biggest leap forward for fire safety by far. Suppression systems are there, but I would say the technology into the battery management systems is incredible.
Emily,
Yep.
concurrence on that?
Yeah, I just wanted to kind of, just echo that. And I know I have that part of one of my slides in my deck, but right, we are testing, monitoring, and have remote control down to that module level and even at times at the cell level. And so, right, we are monitoring it all day, every day, at all hours. And if something is abnormal that we are detecting, to answer that question, directly, right, we will know. And so we will be able to have that remote shutdown. And of course, we do have site techs on, at our facilities that can also, help with that maintenance and replacement if that is something that, were to occur. So to kind of echo Rich, right, we know and we can proactively respond to those abnormalities to our facility to help prevent a fire from even taking place.
Ed, just a caveat on that. At home, that person that asked that question has mostly put a lithium-ion battery on charge that has no rating, that mostly doesn't have the charger that was designed with it, and nobody's monitoring it. Emily's stuff is being monitored 24 hours a day. Guess what? You put it on a charger and you forget about it, and it's mostly still plugged in the garage next to a bedroom. So we've got to put this in that perspective. That's where we're at with that.
Yeah. Okay. Questions from the chat again mentioned. Some of them are really related to the utilization of the storage as an asset, as a resource to the grid, et cetera. Emily, it's really fairly agnostic in terms of that energy can come from any source, and the management is such that it goes into those batteries when there's a surplus of energy, or perhaps maybe when energy is cheaper to produce so that it can be utilized at later points. So it can be paired with any source, including, say wind and solar, for example, as a, just a grid management, asset.
Yep, that is right. And so, I mean, you can even expand your view of what generation is. I mean, coal, in some of our region of the US, nuclear, wind, solar, gas, production, all of that is what our facilities are able to, store. So, right, we do not generate electricity. And so we just store the generation that is being put onto the grid, no matter what fuel type that is.
Okay, question. What are concerns, if any, about battery production? How about your supply chain? Where's it coming from? Are these batteries, and I'll throw in, are they also going to be recyclable at the end of their life? But how is that supply chain and battery production, and what are maybe some of the challenges related to actually getting the batteries that you're putting in place?
Definitely. It's and Rich, I don't know if you're gonna chime in.
Yeah, I was going to say, really, we as a fire service, we've got very involved with the supply chain of it because that's where we're seeing failures. And so we really do a deep dive into supply chain. And the thing that we've found, and the research and the burn test down to the cell level, is this. The person asking that question, you've got a picture that this is a technology, it's a new technology. And when they manufacture it, there's very simple components to this battery. There's an anode, a cathode, a separator, there's some chemistry and some electrolyte. That's it, in the sense of it's complicated but not complicated. So what happens for us is we can follow that food supply chain. We can follow that supply chain. And what we're finding is the main manufacturers of this system, and we say, what is the quality of it? Now, sometimes there is bad quality, but it comes back to that last question. It comes back to, if that's bad quality, I can tell you right now, you have bad quality in your home because we have people dying because of lithium-ion battery fires in their home. No one's monitoring it. The difference is if a bad quality creeps into a large storage facility somewhere in a neighborhood, somewhere in a community in the United States, it is being monitored. And I would say fundamentally, there's going to be bad quality. There's going to be slips in the system. These are millions of cells. But are you looking at that cell and monitoring that cell? Really, that's it. And then what we're finding is because of the chemistry they're using, what happens is if there is a bad manufacturing fault, the more chilled the chemistry is, the less of the reaction. So when we had to use angry chemistry, NMC is angry chemistry. When there was a problem, oh my God, there was a problem. With LFP, it gives you that. Basically, you're able to deal with it, and you're going to be able to do it with a timeline with your suppression systems and your monitoring systems. So we're moving in a fantastic directions. Great questions, but that's where we're at.
Emily, another quick question. Do you have bigger than 4 hour battery systems? I mean, most of these or the ones you've been designing have about a 4 hour discharge capacity. What's the trajectory for longer term storage that we could expect, say, in the next few years?
Definitely. And we're seeing it. It's a good case study in Texas. Like Texas is kind of the breeding ground of, being able to deploy a lot of new technology. And so when we first were developing in the state of Texas, everything was 2 hour, 2 hour, 2 hour, 2 hour. You didn't hear any long-term duration. And then now it is shifting to that 4 hour. And so other states are kind of implementing like longer duration requirements. And so 4 hour will then turn into 8 hour and hopefully longer duration. And so, we will then kind of shift to those longer durations, hopefully in the future. But it's really what the market is wanting. So when when the BESS mandate went into effect, of course, like Consumers Energy and DTE are the ones that are procuring our resources. And what they are looking for is right now 4 hour systems. And so they're kind of the driver of what kind of makes, our facility kind of the design and, of course, the duration. So as they're doing additional studies of how their grid, needs to utilize our facilities, you will likely see that longer duration will come into play, like 8 hour plus. But right now, the market kind of standard is that 4 hour system. So that is why you'll probably see that number pop up quite a bit, is because that's kind of what the state and the end user or the customer, consumers in DT is looking for currently.
Yeah, and I just want to I want to correlate two things that two of our presenters put forward, and there was the mention, and you used the word mandate, and I think the state law from 23 was a targeted guideline of putting 2,500 megawatts of battery storage on the grid by 2030. 2,500 megawatts or 2.5 gigawatts. So, and what Madeline showed on the screen was 15,000 megawatts. So instead of 2,500, there are already plans within the developing community approaching and trying to put projects into the queue to get it actually connected to the grid. That's like more than 10 times what the state law suggested just 2 years ago. And the reason for that is, one, there is the demand. Two, the technology's improved so quickly and the cost comparatively and the value to the grid. All of those things are driving this development of battery storage far beyond what the state law suggested as a target to hit by 2030. I think we're gonna blow past those numbers by tenfold well before 2030. So I just want to point out that convergence of technology, cost, demand is really bringing the free market is driving the demand for a technology that has all these uses. And I know there are people that ask questions about virtual power plants. They've talked about microgrids in the questions, but there's a whole lot of creative uses, I would say, that we can do with this battery storage. And at this point, there was one last question. I'll throw this out, Emily. You mentioned the bigger utilities right now are kind of putting the requests out for what they want to do to meet their needs, as large providers. What about rural co-ops or munis, the smaller munis? Are these just too capital intensive right now in terms of cost for the smaller utilities to take advantage of it, or is there a scale that works for smaller utilities?
Yeah, we've actually seen requests for proposals and for kind of those smaller munis and co-ops, across the board. And I think probably the sweet spot is what you might see as like a 50 megawatt facility, maybe behind the meter. or kind of that 100 MW 4-hour system, we are seeing requests for, proposals for, projects of that size in that co-op space. And so I would say that, I think it's because we now have the first utility scale battery storage project in the state. I think a lot of those munis, I think they want to see a case study, especially kind of seeing the bigger, DTE consumers of the world kind of, leading that charge. And so I do think we'll see a lot more of that going forward. And it is really just something that we can deploy, because of course, some munis have, coal plants and gas peaker plants on their system. And so, if you can kind of imagine that being compatible at that muni level, like battery storage fits right into there. So you will see that, and it's really just the interest level, and then of course making sure that they feel like it is compatible and something that can be a benefit for their end users as well as what DTE and consumers is doing.
Okay. So I'm going to note that we're about an hour and 5 minutes since we kicked this off. So and I would assume some folks' lunch hour, their lunch and learn opportunity is dwindling. We'll stay for just a couple more minutes. We'll do a few more questions, put a wrap on this. Madeline, I wanted to ask you, as mentioning, what are the differences in zoning characterizations or qualifications between different types. And we do have a state law that sets certain standards for setbacks and noise and height and these sorts of things as it relates to battery storage. Have you seen, and I know you and Emily talked about, you've been down to see this first operational battery storage in Coldwater Township. Do you see that communities really have the ability to work with a developer like Jupiter? They can, cooperatively come up with a zoning plan, a permitting plan that's perhaps, goes beyond the standards or is more accommodating than even the requirements of the state law, so that there's a greater degree of local control.
Mm-hmm. I definitely think some of when we look at the numbers of the kinds of projects that have been permitted in the past year, granted that's a really short timeline, when we think bigger picture, the fact that there have been storage projects permitted at the local level indicates to me local governments and developers are finding some sort of compromise or agreement on different kinds of zoning terms. We have captured ordinances, or we have a data set of ordinances in the state. One, all local zoning ordinances to begin with, but then specifically those that have led to wind and solar projects, and read how does the setback compare to PA 233? How does the noise standard compare to PA 233? I have not yet done that for battery storage projects, just because it's so new and we've been really busy, but there's an attempt in kind of like comparing, like, how does it actually end up being permitted, and how does that compare to the state law? From what I can tell from solar and wind, or from solar specifically, is the projects that have been permitted at the local level are definitely more elaborate than what PA 233 kind of sets the guardrails as, and it has worked for developers. So we've been trying to help communities identify, if you can't have all of your wishes in the zoning ordinance because maybe that doesn't work for the developer and they might go to the state, then how can you identify your key preferences? What are you willing to kind of like concede on, and how can that help facilitate a conversation to find a place in the middle that enables that project at the end of the day? So to be continued for data on that kind of stuff.
Yeah. I'm going to throw one more question, which is an Emily and probably Madeline question. Emily, you had a slide on it. It was fairly brief, but given how small the footprint is, like you say, it might be as small as 6 or 7 acres. I mean, we can think of a Meijer store taking up a lot more acreage than that per se, or other land uses. But given its relatively small footprint, but the intensity of capital, from a tax revenue perspective, how much bang for the buck are those local communities going to see in terms of, this is now a commercial operation, it could be the various business tax and so forth, in terms of revenue that it makes available to the community, for schools, for roads, for training your fire department.
Right. So right, each community is going to be unique in their millage rate, so don't want to necessarily just throw out too many numbers. But again, if you have a developer coming to town, make sure if they aren't already leading with, that first conversation with what the economic impacts are going to be for the community. Make sure you're asking them. That is something every developer should know. So definitely lead with that. But what I can confirm is like the investment. So. Like I said, I know I showed a slide that was for Saline Township. That was based off of their millage rate. But it's around for a 100 megawatt 4-hour system. It is anywhere between $150 million to $200 million investment that is going into the ground. And so if you can kind of conceptualize that, that is, I can just use Saline kind of township tax revenue numbers for that life of the project, around $6.2 million for the local schools, 2.8 million tax revenue for Washington County, and then 1.3 million tax revenue for the township itself. And then in addition to some of those additional commitments that a developer can make, if that's, doing a community benefits agreement to help with first responder needs, road repairs, of course, those are things that, a lot of communities should be looking for. And then in addition to that, I know I'd mentioned that Melanie has as well, is that community readiness grant, which is huge. So based off of the size of the project that might be coming to your community, 100 megawatt 4-hour system for Coldwater Township and Saline Township received $500,000 that they can use at their discretion. And so they can, we've seen communities work on upgrading their township hall, improving their cemeteries, improving, bridges and roads in their community, adding a tornado alarm for Coldwater Township. They have a lot of lakes and they wanted to put one out into the lakes. And so that is a huge benefit that the community can use just at their discretion. And so when you're adding all that up, it's, anywhere between two to, plus millions that these communities are going to be receiving for an investment of our size.
Okay. All right. Well, I want to thank all of you again. I think we covered a lot of ground, and I appreciate the insight. The questions were terrific. A lot of good information exchanged here. We all now are going to go and check all of our lithium-ion batteries in our homes. Thank the Captain Richard. And we will attempt, I know we can capture the questions, and to the extent that we perhaps did not answer them as directly, we will find a way to email you folks back if there are very specific answers that we can provide to you. And again, our Emily will email out a link to the recording when we have that available. So with that, I'm going to call it a wrap. And again, thank all of you for participating, and to our panelists. So this would be the time when you click on your Zoom little thing where the hands of applause go across the screen, and we have a great day. So thanks one and all.
Thanks.
Thank you.
Appreciate you all. Thank you.